businesses around the world thrive by having a great team. And what makes a great team are a great set of employees. But what happens if employees join a company but then just leave soon after? That is what is called as attrition, employee attrition. And you can see here over the past decade, since 2013, there's been an uptrend in the amount of employee attrition. And this is becoming a huge problem for businesses because businesses have to invest into the employees. And then that's a huge cost. And then soon after, if the employee leaves, that's a huge loss for the company. So in this video, we are going to be working through a synthetic data set again to calculate and predict the employee attrition at a hypothetical company. And along the way, we are going to look at decision tree classifier and how we can visualize the tree it generates, and how to go about looking at the feature importance from these modeling techniques, and a few other plots as well. So hopefully this is going to be a really good introduction into decision tree and give you enough insight into this real world problem of employee attrition.
So we'll start by bringing in our handy libraries, that is pandas and numpy, which we always use in our tutorials. Let's bring them in, and we're going to set np.randomSeed so that all the random data that we're generating kind of becomes repeatable in the subsequent runs that we do for analyzing similar data. So we'll do that, and we have a few columns over here: age, salary, years at company, and attrition. And these are all random variables, so I can just bring them in and finally also put them into a data frame by passing all of this in as a dictionary: age, salary, years at company, and attrition, which are all coming from here. And then we finally have a data set. If I open my data frame up, you'll see that this is how it looks like. We have the age, salary, years at company, and finally the attrition column as well, where 1 denotes the employee did leave the company and 0 denotes the employee did not leave the company. So this is a good data set to be starting off of, and we will work through building a decision tree now. So here we are bringing in the decision tree classifier, and I'll also explain how decision tree works to give you a very high level intuition of the inner workings. Before that, let's also bring in train test split and accuracy score. And as you've seen from the past few days videos, you'll probably understand that these are some of the components which are kind of repeatable. So if you're building anything new, you probably do the same thing again and again. And that's the whole point of doing these series of videos anyway, to give you a quick blueprint on how to get started with some of the problems that you might encounter in real world. To get a quick understanding of how decision tree works, let me just pull this visual up where we have this obviously looking tree over here, and that's not the point, but what we're interested in is over here where we have these branches and these nodes. So if you will, we start off here with a base condition, and then if some base condition is met, we go either over here or there. And this again nodes splits off into 2 other nodes, and then these goes on as deep as we want. So actually, as much deep as you want is one of the parameters that you can specify in the decision tree. But in a very simple nutshell, this is how it works. You have like the tree structure where we are going from one leaf to another leaf to another leaf, also called as nodes. And then finally, you have a sort of like a decision that you can put all of them together and then arrive at a final output that you're looking for. So if you see in the name as well, we have decision tree classifier. So this is very similar to some of the other things that we've already looked at, where we looked at like logistic regression, and maybe in the future we'll look at XGBoost. And in that same family where we're trying to classify into finite set of outputs. So in this case, employee left the company or employee did not leave the company, or in the credit risk analysis that we did, if it's a default versus non-default. So these are all like classification problems, if you will, compared to like the regression where we're trying to predict something on a continuous time scale, right? So these are the 2 main important problems, and we're solving this classification problem here using decision tree classifier. So all the things that we talked about, the confusion matrix, ROC-AUC curve, recall, precision, all these things appear and apply over here as well. So all that being said, let's get back to doing some real things instead of sitting through just the explanation. So let's go and bring in our data and then add all our features into a variable called X, and then all the dependent variable, which is the attrition, into the Y variable. I'm calling this the dependent variable because the value of this is dependent on these independent variable: age, salary, years at company, and so on. So let's bring this in, and we have the X and Y data, and I can just open this up where we have age, salary, and years at company, and Y will have just the column attrition. So this is good. Next, we want to train test split. Similar to what we've done in the past, we'll assign 70% to the training set, and then the test set will have the remaining 30%, and then we give it a random seed as well. Let's do that. And running the model is as simple as initializing it and calling model.fit on it with these two values, right? So let's do that as well. So there we have it. We've just trained our decision tree. We can also do some predictions on it because our model hasn't seen what's in X test yet. So we haven't produced this to a model yet. The model has only seen the X training data set, right? So we can test on this data set and then see what kind of accuracy we get. So we can run this and the accuracy. So for the accuracy, we are giving the Y test, which is coming from here, and our prediction that we got from the model.fit over here, actually over here. So let's run that, and then I can print the accuracy, and it's about 66%. Again, we have to look at the decision trees, confusion matrix, and precision recall and other factors to really decide if this accuracy is good enough for us. But nonetheless, let's move on, and then this is exciting where we can visualize the tree that the model produced. So I'll just run this. So you see we have a tree that looks like this, and it's similar to what I showed initially with the tree structure. So we have the age, it's classifying anything under 21.5 is coming to true, and then everything else is going to false. And if you looked at my detailed video, I also go and talk in detail about the Gini index and how all these things are calculated. But for simplicity's sake, just to get an intuition of how all these things work and to get a high-level overview of all these algorithms, this is good. So you can see next is years at company, and then again, there's a yes and a no. And what I've done here is, because this is a huge tree actually, so I've just limited it to maximum depth of 3. Now, if I take this out and then run the same commands again, you'll see that my tree is actually really, really dense. And even if I try to zoom in, I won't be able to read any of these texts. And that's why I put maximum depth 3 so that I'm able to at least see the major factors which is used in deciding what to split the data on. So now that we have that, let's also look at the feature importance, because this is an important thing, because we have age, salary, and years at company. But among these three, which one contributed the most in predicting the attrition of an employee? So that's where feature importance comes into play. We can bring this in, and then we call model.feature importance, and you can just have x.columns as the features, and then we are going to plot the features against the feature importance. And this is a regular matplotlib plot. And let's see what we have here. So we have age, which is, I guess, 0.25 importance. And then salary feature, salary is actually the most important. More than half contributes to employee either staying or leaving is salary. And who knew, right? That salary was so important. But yes, years at company is again somewhere on here. So age and years are okay, but yeah, of course, like we've all seen and heard and thought about, salary is a huge deciding factor on if an employee stays back at a company. So now that we have that, let's also do some predictions, which are quite interesting. Let's create a simple function which isn't doing much. We just get the input data out of our data frame and then do a model.predict on just that input data and get our prediction. And here we are saying age is 35, salary is that much, years, and then we want to see if the employee stays in the company or not. So let's see what this gives us. Okay, so if an employee is 35 and then earning 20,000 and been at the company for 10 years, then it's saying, yeah, this employee is going to leave pretty soon. Another way of looking at this is employee is at risk at attrition, and there are things that the employee can do so that they're more productive and stay back. So offering like training program and other things are good. So this is exactly same as what we did here, but instead of just returning prediction, I'm just printing out a message here. So there's nothing fancy going on here. Let me just print this out and let's run this example again. So we have employee is at risk of attrition and the model recommends training. But what if we added a few more zeros to this person and see if this person churns or stays back? And let's run this. So that result was still producing attrition, but I changed the age to 25 and then 20,000. and then years of company at 5, and now it's saying employees not at risk of attrition, no training program required. So if this person is you, then yeah, there's no training program required in this hypothetical scenario that we're playing with. So hopefully the point of this was to introduce you to decision tree classifier and how to think about this in terms of a tree. And even though there's a lot of features going through, but ultimately we are just getting one output out of it, saying if it's 1 or 0 or finite number of classes that you've defined. So I'll see you in tomorrow's video.